Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Chaiken at the University of Albany and his brother Joel Chaiken. We're here to help you approach SAT math questions. This is still a non-calculated question, but it is not a multiple choice question, which means you have to, what's called a free response. You have to answer an actual number or a decimal or a fraction. A number, one of those things. It could be one of those. Positive, negative, zero, whatever. Okay, here we go. Make it a nice thin line, and we get to start. Okay, so please read it over, pause it, and then come back, and we'll do it. Okay, Jim has a triangular shelf system that attaches to a shower head. Oh, wow. The total height of the system is 18 inches, and there are 3 parallel shelves as shown above. What is the maximum height in inches of a shampoo bottle that could stand upright on the middle shelf? Okay, so this is both a geometry question and an algebra question and a ratio question, etc., etc., etc. So, if you know how to do this, you basically do 2x plus 3x plus x is equal to 18. You add these up carefully. That's 6x is equal to 18. X is equal to 3. If x is equal to 3, then the maximum of this could be is 9. 9. I don't think you say inches. On a school test, you would say 9 inches. And they say in inches, so the answer would just be 9. Now, how do you do that if you don't know how to do that? That's the question. How do you do that if you don't know how to do that? But it's sort of common sense, right? The 2x, these are the sides. 2x plus 3x plus x have to add up to the total. Very often, this question could be written as a ratio. You have a ruler or some piece of fabric that's 18 inches, and you want to break it up into 3 pieces in the ratio 1 to 2 to 3. How big is each piece? That's usually how it's said. And if then you have to basically the best way to do that is simply that. This problem is so common that it's a very good idea to know how to just do that problem. You have a total number of things broken up into certain ratios. How do you do it? You do 1x.
Yeah, well, here is a thing that's broken up into a constant length and 2 lengths that are ratios of each other.
No, it's 3 lengths.
No, that's an x. Oh, I didn't see it. Okay, that's an x. All right. Yeah, no, you're right. Yeah, so it's broken up in ratios. Oh, wow. My eyes are this far away, so my eyes don't see it that well. Okay. Yeah, so this is x, 3x, and 2x. Okay.
Yeah.
Right.
So
okay.
I think that's pretty standard way to approach it.
Yeah.
The other way to do it, if you don't see it as a ratio, is you literally see these as 2x, 3x, and x, and you say the length is equal to the length, right? The length on side 1 has to equal the length on side 2. The length of side 1 is 2x plus 3x plus x. The length on side 2 is 18. You smile. This is a 1 equation, 1 unknown. You can solve for x.
Yeah, sure.
Okay.
All right. Well, I think it's a pretty unrealistic problem. A more realistic problem is, a designer wishes to design a shelf system. The total height should be 18 inches. The top portion should be twice the height as the bottom portion. And the middle portion should be 3 times the height of the bottom portion. Right. What should be the heights of all the portions, or perhaps they should say, what should be the height of the middle portion?
Yeah. So that's this problem.
Yeah.
That's the ratio problem. Given as a ratio.
Yeah. Okay.
Okay. I guess we're done, right?
We're done. Yeah.
We're done. Okay. Today is Throwback Thursday. Congratulations. We get to go back.
Congratulations.
We go back 20 years or whatever, which maybe sometime we'll go back even further. But right now, we're only going back 20 years to tests that are in the early millennial, whatever early 2000s. And we've already targeted a nice question. We just do the Ziteboard thing. There it is. Today's day is 12/8. And we're going to do this one, which feels like a, first of all, chap, can you imagine that? 6 sections? The old test used to have 10, like 8 or 9 sections, shorter time, and one of those sections actually did not count. It was a test section.
Oh.
But now the test
to keep you tired.
What they want to do is they want to put test questions on. And but that's gone. Maybe now they do have test questions, but there's no such thing as test sections. Anyway, so here it is. The 3 different circles are drawn on a piece of paper. At most, how many points can be common to all 3? So this really sounds a little bit like a combinatorics question, like last Thursday, doesn't it?
I don't think so.
How many, at most, what is it? At most, how many points can be common? Can we make any more than that?
Okay.
What happens if you have...
Well, this is this seems like this is a geometry question, and it's a question where to be sure you're right, you have to use some logical reasoning in geometry. So I think I know what to say. So should I?
Yeah. See, I did it wrong.
I think I have the idea in my mind.
I have 5, and 5 isn't even a choice.
No. It says how many points can be in common to all 3.
Okay.
So this is no good because you need. Yeah.
So go ahead.
Okay. So here's the idea. First, as Joel drew. Here are 2 circles. Oh, see that? They're not really circles. So let's make nicer circles. Here are 2 circles. And this is an example in which they have 2 points in common.
Okay.
So so the most number they could have in common is at least 2.
Right.
Perhaps it's 3. So here we go. This is the trick in the reasoning. Instead of thinking of the circles, think of the points.
Okay.
So let's take 3 points in general position. Right here, 3 points in general position. And let's examine what circles can go through those 3 points and see if we could find any circle or one circle or more than one circle that can go through these points. If we could find more than one circle through these 3 points, then the answer might be 3 or perhaps even bigger. But here's what we could do in geometry. It's going to involve an argument involving straight lines. So I'm going to take out my little straight edge and try to draw straight lines. So I'm going to draw a straight line between this point and this point. All right, it's hard to use a straight edge here. Okay, how do we do this? Get this here. Here.
You know, there's the option
right, now watch
to
this.
draw a straight line.
They draw a straight line between this point and this point. What happened?
You can draw a straight line.
Don't move it, please.
I'm not moving it.
Okay. Something went wrong. I'll have to do it freehand. This is not...
Just do it freehand. Just do it freehand.
I will do it freehand.
We get the point.
Hold on. No. I have to do it carefully. Here's our straight line between these 2 points. Right? Now, I will draw another straight line through these 2 points. Okay?
Okay.
Now, any circle that goes through the first 2 points must have a center that is on the perpendicular bisector of the line segment between the points. So I shall, they're not in general position. They look too perpendicular. So let me undo it a bit. Let's put them in a more general position. So I think something like this. Okay. Sorry. I'll put the points in blue. And we're kind of general position, right? There we go. Now, so what I'm going to do is first draw the perpendicular bisector. I first draw the line between here and here, and then the sorry. Come on. Oh, come on.
Seth, can I just
hold on. Give me time. It needs patience. Okay, there's the point. There's the other point. Now, I'll draw the line between here and here, and the line between here and here, right?
Okay.
Okay, now I'm going to draw, here's the idea. Draw the perpendicular bisector between these 2 points. Oops. Oh.
Yeah, okay, then that makes
sense. Hold on. Now, any circle that goes through these 2 points, A and B, has to have a center that's on this perpendicular bisector.
Okay.
In the same spirit, I will draw the perpendicular bisector that goes between points A and C.
Right.
That perpendicular bisector will look something like this. Now, any circle that goes through A and C must have its center on the second line.
Right.
Right? But because these 2 perpendicular bisectors are intersecting, because they are not parallel and they're not coincident, because they're in general position, there is only one point in the whole plane that can be the center of a circle that goes through all 3, A, B, and C.
Right.
So if for any 3 points, in general position, there is one circle and only one circle that can go through all 3 of them.
Okay.
So it's impossible for there to be 2 circles that are different that go through the same 3 points.
Right, okay.
And therefore, we have found 2 circles with 2 points in common, but if there were to be 3 points in common, there can only be 2 circles, because there can only be, if we have 3 points in common, there cannot be two circles that go through the 3 of them. So if there are 2 points in common, we could find 2 circles that are different that go through them. But for 3 points in common, there's only one circle that can go through all 3.
Okay.
And so the answer is not 3 or more, and we know that it is certainly 2.
Seth, but it's 3
and
circles.
Therefore the answer is 2.
Seth, what are you talking about? What are you talking about? It's 3 different circles. What are you talking about?
Yeah.
It's 3 different circles. It's not 2 different circles. It's 3 different circles.
Oh, 3 different. Okay. Okay, so still,
stop,
you cannot have 2 circles through 3 points, but you can have 3 circles through 2 points, like that. You could have lots of circles. Given 2 points, you could have a big circle through them. You could have a diameter circle. You could have what would it be? It would be could have a circle like this.
Seth.
You could have lots of circles through two points.
Seth,
but you could only have one equal circle between 3 points.
Seth, stop.
Okay, I'm done.
Stop. What question are you answering? You want
no, as you see, I made a mistake.
Seth, okay.
The question that
Seth, let me speak.
answered the wrong. The question. Let me start again.
No.
The question that I will answer.
Stop. Am I gonna have to mute you? Stop.
No.
Let me try it. Okay. Let me.
Okay.
Okay. Let me see what's going on. What about this situation? You have circle here. Oh. I was gonna draw a circle here. That's not a circle. Oh.
No, it's not a circle.
I was gonna go like that.
No.
Oh my God.
That's an ellipse.
Yeah, that's not a circle. That's an ellipse. That's a different question. So I have circle here. Oh. Then, maybe big circle. Oh, and then you can't. Oh, wait. Then you can go like this, though. You can go like that, right? 1, 2, 3, 4. But I was able to do one with 5. I was able to do one with 5. If you have these guys, there are 5 here. 1, 2, 3, 4, 5. I just drew 3 circles with 5 points in common. So, but 5 is not an answer.
No.
5 is not
they're
an
not.
answer.
This point here.
Oh, that are common to all 3.
That are all 3. Yeah, this point is
right.
not
that
common.
Point's not common to all 3. That point's not common to all 3.
That's right.
Wait. What about my example? This one, in this one, none of these. Oh, this one's common to all 3. And this one is not common to all 3. Oh, I see. So it looks like it's 3. Doesn't it? Looks like it's 3. You go like this. 1, 2, 3. It looks like it's 3. Okay, I'm done. Now, Seth, please answer the question.
Okay. Well, what do you think the answer is?
I don't know what the answer is. I would say it's probably. I wouldn't spend that much time on this problem if I was on the SAT, which means I probably would do. I wouldn't have done as well in this test. The old tests. But
let's look at that configuration of 3 circles.
Wait, this doesn't even. This one doesn't even. Yeah, this one does go through all 3. Right? Yeah. I would say 3.
Wait, tell me about what's in common, and to say what you're going to say in a complete sentence.
Okay.
Draw the 3. What do you call the circles?
Interlocking. 3
circles. Interlocking. Yeah.
I would say I would just take a chance with 3, and maybe other way to do this, but I would say 3.
Okay. Now. Okay, so the question is, those are 3 different circles, right?
Right.
What points are common to all 3 of them?
Yeah, A, B, and C.
Okay, pick A. All right. A, mark one circle that contains A.
Okay, I'll
put a 1 on it.
No, I'll mark it in blue. I'll mark it in purple. That's a circle that contains A.
Okay. Oh, really?
No, it doesn't contain A. Oh, it doesn't contain A. Oh, yeah, it doesn't contain A. Oh, well. It doesn't contain A. Does not contain A. Doesn't contain A.
Okay, show us a circle that does contain A.
Okay, show us a circle that does contain A. This circle contains A.
Okay, now find another circle that contains A.
Okay. This circle contains A.
Okay, great. Right. Now, can you find a third circle that contains A?
If I wanted to.
No, among the 3 that are given.
No, but I could draw a circle that contains A.
Okay, draw a circle. Draw another circle that contains A.
I'll make it a thick brown.
Yeah.
There.
All right, good. Great. So we have now. Oh, find a circle. No, sorry. Find a point that's in the brown circle that belongs to another circle that also contains A.
I'll find a point. Yeah, I see. I think I see where you're heading. B? B?
Okay, B is not on the brown circle.
Yes, it is. Now it is. Yes, it is. That green dot.
The green point is both on the brown purple and the green point is on the brown circle, the purple circle.
But it's not on.
And the brown point is also on the brown circle and the purple circle. Right. Now, could you find a third point that's both on the brown circle and the purple circle?
Yeah. No.
No.
No, I can't. I can't find another point that's both brown and purple.
Yeah. So can you find any two circles that have 3 points in common?
Well, unfortunately, that green dot does not have 3 points in common.
Yeah.
And this pink dot, the red dot here, doesn't include B. Wait, why can't I read?
Yeah, here we are. Here's a
what happens if
here's a circle.
I go
right. Oh, yeah. Sorry. How come it's squiggled like that? Okay, here we go. Here's a circle. Here's my first circle. And I'm going to draw another circle that has 3 points in common with this circle. 1, 2, 3. Actually, it has 4 points in common with this circle. But that's not a circle.
That's not a circle.
Let's try this. Okay, here's one. Here we go. Here's 1 point. Here's another point. Like that. 1, 2. This has 4 points in common. We could do tangents.
That's not a circle.
Yeah, we could do a tangent thing. There's a point tangent there that goes through here and here. 3 points in common.
But that's
not a circle.
That's not a circle.
Okay, so no matter what you do, you cannot find. Well, suppose you did find. Suppose you did find another circle. You don't know where it is. That had these 3 points in common with the given circle. Right? Well, that circle, since it has 3 points in common, if it had these 3 points in common with this circle, its center must be along this line. And similarly, its center, that second circle center, must be somewhere along this line.
So it has to be the same circle. You're just telling me it's the same circle.
But these 2 points cross at only 1 point,
right?
And it happens to be the center of the original circle.
Okay, so.
Okay, so right. You can't have a second circle that contains these 3 different points in common with the first circle.
Right. Okay.
And therefore, you cannot add a third circle.
Right. So in other
that goes through these 3 points.
In other words, you're saying the answers can't be 3 or 6.
Yeah.
Okay. Fine.
So I propose. I vote for the answer being 2.
2. Oh, I see. Oh, it can't be 3 or 6. So then you start going this way, and you actually can prove that these do. Wait, let me see which ones they are. Two? Which are the two? This one, no, that one doesn't go through all three. So what's an example where they go through all three?
There's no example.
No, two. What's the example that they go through?
There are lots of them on the picture, on the page.
There are 2 points here that go through all three?
The purple circle and the yellow circle.
Oh, this point. No, that point doesn't go.
Yeah. These two circles.
Wait. Purple circle.
I'm sorry. The question is about 3 circles containing 2 points in common.
Yes.
There are lots of them. Here we go. Take a little circle.
So let me clear all my stuff.
Yeah.
Okay, let me clear all my. There you go. Now you have some space.
Yeah. This circle, the blue circle, that's 1. Oh, why does it do that? The blue circle, 1. The blue circle on the right is 2. And then draw a big circle. Goes through the 2 points. Goes all the way around like that. And that's circle 3.
Oh. And then you can also go like this.
Yeah.
And then you can
so
draw,
in general, let's draw this. Draw a vertical line.
This way, can't
2 points on it. There's a circle with a very large diameter. Goes through like this. A circle with a slightly smaller diameter that goes like that. A circle with a little bit more of a smaller diameter. Well, you take the circles. Here's our big diameter circle. And we have a circle like this. Circle like this, and a circle like this. Circle, it's hard to see.
Right.
It's could draw a whole bunch of
different cases, right? You have a
different cases,
like
that.
You have a circle like that.
Yeah.
Right?
And in fact,
and then you have a huge circle like this.
Yeah. Say more rigorously. I'll do it in black for you. Black. Draw a vertical line.
Wait. So let me go over the idea how you did this. You proved that you can't have 3.
You can't have 3, yeah.
Okay, so if you can't have 3, then you hunt for 2.
Yeah.
And you can, with some imagination, come up with 2. With this one, this one.
Oh, wait, what are we talking about?
This one.
Are you talking about 2 points or 2 circles?
No, we're talking about 2 points on 3 circles.
Oh, 2 points on 3 circles. Okay.
So in other words,
2 points. Okay, 2 points on 3 circles. Here we go.
No, Sam, I know
Stop.
that.
2 points, 3 circles.
I know.
Stop. I will draw a vertical line. Here are our 2 points. Then I draw the perpendicular bisector between the 2 points. Then I pick an arbitrary point here. And the distance from the X point to the black point here, the top black point, distance from X to the bottom black point, those 2 distances are equal.
Right.
Therefore, there's a circle whose radius, whose center is the X point and goes through these 2 points.
Right.
You agree?
And why are you making it harder than it is?
Because now I draw another X point, different. Its distance to A and to B are the same.
Yeah.
So draw a second circle. centered on the second X point. Now pick an X point over here, a third one.
Fine.
Or a fourth one.
Yeah.
For each of them, the distance to A and to B are equal.
Right.
So for each of them, there is another circle that goes through A and B. If you put 1,000,000 different X points, you get 1,000,000 different circles.
We know that. We know that.
So you could draw. You could pick three different X points and get 3 different circles all through A and B.
Right.
So for 2 arbitrary points, you could find 3 circles going through them.
Yeah.
But for 3 arbitrary points, there's only 1 circle going through them all.
Okay, that's not the question.
This is the question.
No.
We need this construction to show that the answer is 2 or more, and you need the other argument to show that it is not 3 or more.
Seth, wait, stop. First of all, you were very smart in understanding that it can't be 3, right?
Right.
It can't be 3. If it can't be 3, then it has to be less than 3, right?
Right.
So then all you have to do is show an example of 2 and you're done with the problem.
No, 2 points, 3 circles.
Yes. All you have to do is just draw an example and you're done with the problem.
Yeah.
You don't have to do all this theory.
So there it is, 2 points.
Yeah, we have it right here.
Okay.
We're done. You have an example of 2. You have an example.
This figure is a little hard to, maybe it's a little hard to imagine.
Yeah, but your theory is even harder. You don't have to use the theory anymore. Once you realize it's not 3 and not 6, then you start going down, right?
Okay.
So you try 2. You use your imagination. Can you come up with the 2? The problem is most people are not going to be able to use the argument you use to understand that it's 3.
So stories. This is an older SAT question that dates back to the days when they had a full course in geometry.
Wait, no. This is really hard stuff.
They used to teach in 10th grade. Was it 10th grade math?
No. They stopped that 40 years ago. That 40 years ago. No, you have to really know what you're doing to make the argument you made. Yeah. To make the argument, it was very sophisticated to show that it can't. It is, yes.
So people, our audience, will learn how to make really sophisticated arguments if they watch us enough.
Well, frankly, I'm going to have to watch that over 3 or 4 times to understand what you did.
Yeah.
I didn't really follow it that well, but this is recorded. So if you didn't understand the argument Seth made as to why it can't be 3, and therefore it can't be greater than 3, go back to this argument and watch it, and wow, maybe we'll learn something. I may watch that too to understand a little bit more about that argument. Okay, wow. So this was.
Okay, I wonder if we should simply clear the page and make a brief summary and reminder of the 2 arguments.
Emphasis on the word brief.
What's that?
Emphasis on the word brief. Okay. Brief.
Brief.
Do it
briefly.
Right. Do it briefly. Don't.
Okay.
Do it briefly. Okay.
Okay, now, we'll do it briefly.
Do it briefly. Please do it briefly. And anyone who says
tell me to do it briefly. Briefly.
Okay. I love you, Seth. You're great. Okay, go ahead. Briefly.
Okay.
Briefly.
Argument 1.
Briefly. Go ahead.
Here are 3 circles with 2 points in common.
Be patient. The Zypert will have to paint. Okay.
2 points in common. Here's 1 point. Here's another point. I will draw the perpendicular bisector. Let's find 3 circles that have these 2 points in common. Circle 1 has X as its center. Circle 2 has Y as its center. And circle 3 has Z as its center. So the circle with Z as its center is like this. Yep. The circle that has Y as its center, something like this. And the circle with X as its center looks something like this. Okay. So here we are. You really have a anyway. So there that shows 3 circles. Like this thing is dragging.
Yeah.
3 circles. 2
points.
2 points. Now, 2 circles. Okay, 2 circles, 3 points. Is impossible.
Okay. Okay.
And the argument there was, if we had those 3 points given, you could draw the perpendicular bisectors between the lines. One perpendicular. These 2 lines are equal. These are equal. You get a single center, and you can only find 1 circle containing 3 points. And therefore, you cannot have 2.
Got it. Okay. Fine.
So there are 2 arguments. I'll use Roman numerals 1 and 2. Yep. 1 shows that the number of points possibly in common with 3 or more circles is 2 or more.
It's not 2 or more. It's just 2.
2 or more, because we haven't proved that having 3 in common with 3 circles is impossible.
Fine.
And argument number 2 shows that the answer has to be 2 or less.
Got it.
And therefore they intersect. Has to be 2.
Okay.
The answer is 2.
Okay. Good. Okay. And the way I viewed it is this one, once you know this, then you just look for an example. You don't waste your time with the theory. You just look for an example. And then you find an example that has 2, and then you're done with the problem. Okay. Different ways of approaching the same problem. Okay, but
Well, sorry, you needed to find 3. 2 points, 3 circles.
Yeah, of course. You just have to come up with a way to draw
2 points, 2 points, and 3 circles through them.
Right, exactly, which is fairly easy to find if you try it. You can usually find that. Okay, but you have to be pretty smart to do this problem. Okay,
but you have to have your eyes open and be open to reading what it says and putting it in your mind as it's described.
Yeah, right. But I made some really bad mistakes by going like this and saying that these were in common, because it turns out that like this one was not in common to circle A. So I probably would have gotten this question.
Yeah. So what we're talking about is what it means. What does it mean for some circles to have 1 point in common?
Yeah.
And then have a different point in common.
Yeah.
And then have a 3rd point in common.
Right. Obviously.
Yeah.
Okay, I think we are seriously done. Like
Seriously, John.
Seriously.
Okay.
Okay, everyone.
Oh.
Throwback Thursday is exhausting for us.
Exhausting.
Exhausting. Okay, so we better go. Okay, everyone.
Gotta go.
Yeah, give us your comments. Hopefully they're good. Although this time was, I don't know. This is a weird one. And anyway, we'll send us your SAT math questions at SATmathQuestionOfTheDay at gmail.com. Okay, bye everyone. Have a nice Throwback Thursday. Bye.